Alright, I'm going to say more often than not, inverses are going to be represented by that f inverse. It almost looks like f to the -1, but it's never ever been called that. That is always representing the inverse when it's got that to the -1 looking thing. On E, I'm going to go ahead and link another short video on how to use your guys' inspires. That was one of my weak points in a year previous, so I'm just going to go ahead and link a video, which is pretty nice, to show you guys how to do that on your guys' inspires, which are now College Board approved on the AP test, more recently than not. Alright, moving on to functions and logs, verifying and proving inverses. So, a couple sections ago I said, okay, well we got this whole thing, it equals x, so that means that it could possibly have an inverse, but we'll see later. Now is later. So, let's get started. So, to find an inverse, either algebraically or graphically, is definitely one thing, but being able to verify it and say that two functions are actually inverses in mathematics is to basically go back and use definitions. So the definition of an inverse, it says a function of f has an inverse f inverse if and only if f of f inverse is equal to x, which is equal to the f inverse of f of x. So according to this definition, how many composite functions must you check whether or not two functions are inverses of each other? Well, we're definitely having to check whether or not f inverse plugged into just regular f function is equal to x, and we're checking to see if f function plugged into the inverse is also x. So according to the definition, we have to check 2. Alright, let's go on to example 5. It says find the inverse and verify if f of x is equal to x plus 3 over x minus 2. Alright, so finding the inverse isn't too bad. All that we're going to do is we're going to take our original function, which is that f of x is equal to x plus 3 all over x minus 2, and this is basically just going to become a y, and we're switching our x's and our y's. So now we've got x is equal to y plus 3 over y minus 2. Alright, so now let's solve for y. So, getting another pen color just to show things. I'm going to multiply everything by that common denominator. So multiply this side by y minus 2. And multiply this side by y minus 2. So all in all, I should just get x times the quantity of y minus 2 is equal to y plus 3. Alright, now I'm just two different ways to go about this, but I think I'm going to go about the way of x times y minus 2x is equal to y plus 3. Alright, I'm going to get my y terms to one side and everything else to the other. So I'm going to subtract this xy term over to the other side. So I'm going to get negative 2x is equal to y plus 3 minus now xy. Subtract that 3 over, I get negative 2x minus 3 is equal to y minus xy. And then I can factor out a GCF now on my right-hand side, which happens to be, y. So I'd get negative 2x minus 3 is equal to y times the quantity of 1 minus x. Alright, still trying to get y by itself, so I need to divide off that 1 minus x over to the other side. So all in all, I should get, let me switch pens, we should get negative 2x minus 3 all over 1 minus x is equal to y. Alright, like I said, finding it's not the hard part. Proving, verifying that we have an inverse is the more pain in the butt part. So now I get to show that f of f inverse is equal to x. Fun time. So basically what I'm doing, I'm basically writing my f function, which I started with, and I'm leaving anywhere that I have an x blank, because now we get to plug in that inverse anywhere that I saw an x in my original. So leave enough space. Alright, so I can think of a math f word that is not fun or function times that we are going to now have to do to try to get this entire thing just to be x for funsies, right? So, let's go. It's never going to get any easier if we never start. So now I'm trying to multiply through by that common denominator because I know 3 is over 1 and that 2 is over 1. And so my common denominator between all of these little fractions should be that 1 minus x. So now I should just have f of blah, which is negative 2x minus 3 over 1 minus x, should be equal to now negative 2x minus 3 plus 3 minus 3x, all of this over that 1 minus x, all over negative 2x minus 3 minus 2 plus 2x, all of this over 1 minus x. Alright, so now we do this whole keep, change, flip, copy, dot, flip, whatever the heck you guys want to call it. And we should see that our denominators are going to cancel. Bada bing, bada boom. Leaving me with that f of now negative 2x minus 3 all over 1 minus x should be equal to negative 2x minus 3 plus 3 minus 3x all over negative 2x minus 3 minus 2 plus 2x. Hopefully I can skip to that part. Alright, may have to widen my page out a little bit just because I write large. Alright, so hopefully at this point we are good with combining like terms. So these will cancel, leaving me with negative 5x up top over 2x's will cancel, leaving me with negative 5. Negative 5 over negative 5, that's going to cancel out, leaving me with just x. Which means, yay, it's possible that I might have an inverse. On the other hand, oh no, it makes more work for us. Because now we get to go the other way. Yay! So now we get to see, okay, is f inverse of my original function equal to x? Alright. So I go find my inverse, that was this hot mess, and anywhere that I see an x in that mess, I'm going to plug in my original function, which is what I've done so far. So now, just like I did, I'm going to multiply through by that common denominator, because I know that 3 is over 1, 1 is over 1. My common denominator should be that x minus 2. Alright, so multiplying through, this is what... Oops, I had a little bit too much there. I forgot that those two things should cancel for a second. Brain fart. Alright. So go ahead, keep writing. Copy dot flip should cancel these out, leaving me with just. Alright, keep going. Now you just combine your like terms, so your x's cancel it out down here, leaving me with just negative 5. My 6's are going to cancel up here, leaving me with just a negative 5x up top. And now my negative 5's cancel, leaving me with just that inverse. Should be equal to x. So in the end, you'd end up saying some short sentence like, since f of f inverse is equal to x, which is equal to the f inverse of f of x, and f inverse of x are indeed inverses. Yay! We didn't do all that work for nothing.